Welcome to World Decoder. Today we explore the ultimate engineering pinnacle of warfare, diving deep into the terrifying hypersonic Fatah missiles. Hypersonic technology is currently considered the ultimate holy grail of global military power, shifting the balance of modern strategic warfare forever. Iran has firmly asserted its undeniable position on the global stage, with the rapid development of the deadly Fatah missile family. To truly understand why the Fatah series is such an absolute nightmare, we must examine a terrifying physical speed comparison. Operating at Mach 15, this weapon travels at exactly 15 times the speed of sound, tearing through the upper atmosphere. At this unimaginable velocity, the advanced missile easily covers a staggering distance of approximately 5 kilometers every single passing second. With such blinding speed, the available reaction time for enemy air defense computer networks drops down to almost absolute zero. Human operators cannot possibly track this threat, leaving entire military bases completely vulnerable to sudden and devastating precision hypersonic strikes. Radar systems struggle to lock onto the incredibly fast target, making traditional interception methods practically useless in a real combat scenario. The sheer kinetic energy generated by this incredible speed alone can obliterate heavily fortified bunkers without needing explosive warheads at all. But the newer Fatah 2 is not merely fast, it is also incredibly smart, introducing a completely new tactical strike paradigm. The core difference lies within the highly advanced Hypersonic Glide Vehicle, mounted directly onto the front nose of the missile. Unlike traditional ballistic missiles that strictly follow a highly predictable parabolic flight path, this new weapon behaves very differently indeed. Older missiles travel through space in an arc, allowing defense computers to easily calculate their exact future impact location instantly. However, the Fatah 2 glide vehicle possesses the unique ability to autonomously adjust its flight direction while still inside the atmosphere. Imagine firing a sniper bullet that can magically change its trajectory in mid-air to actively dodge incoming defensive interceptor fire. This incredible maneuverability transforms the missile into an unpredictable phantom, weaving through the sky with terrifying grace and lethal precision. Advanced defensive shields like the Israeli Arrow system suddenly face a completely unsolvable mathematical equation regarding the incoming warhead's trajectory. The mighty American Patriot batteries also struggle immensely, unable to predict where the agile hypersonic glider will strike next accurately. By constantly shifting its altitude and heading, the weapon systematically bypasses overlapping radar nets designed to protect high-value strategic targets. This evolutionary leap in missile technology effectively renders billions of dollars spent on traditional air defense infrastructure completely obsolete overnight. The glide vehicle rides the shockwaves generated by its own supersonic speed, essentially surfing through the dense layers of Earth's atmosphere. But achieving this miraculous feat of engineering introduces a massive physical obstacle that scientists had to overcome with great difficulty. The absolute biggest challenge of hypersonic flight is not the propulsion system, but rather the extreme limits of material science. Traveling at Mach 15 through the atmosphere creates an unbelievable amount of aerodynamic friction along the entire missile outer casing. This intense friction violently compresses the surrounding air, generating a superheated layer of glowing plasma that completely engulfs the flying weapon. Temperatures inside this raging plasma sheath can easily skyrocket to several thousands of degrees Celsius in a matter of milliseconds. At these hellish temperatures, conventional aerospace metals would instantly melt away, causing the missile to disintegrate catastrophically during its terminal phase. The fact that Iran successfully manufactured a functioning heat-resistant shell proves their undeniable mastery over highly advanced modern material sciences. Special carbon composites and classified ablative coatings are likely utilized to absorb and deflect this immense thermal energy safely away. These exotic materials slowly burn off during flight, carrying the destructive heat away and protecting the delicate internal guidance electronics inside. Without this crucial thermal protection system, the advanced onboard computers would fry, rendering the hypersonic glide vehicle completely blind and useless. The plasma sheath also creates a unique communication blackout, blocking external radio signals from reaching the missile during its final dive. This means the weapon must rely entirely on its own internal sensors and autonomous artificial intelligence to find the target. Fatah 2 stands as a terrifying testament to human ingenuity, blending raw destructive power with incredibly sophisticated autonomous flight control algorithms. It is no longer just a simple explosive projectile. It is a highly intelligent hunting machine, operating at extreme hypersonic velocities. This technological breakthrough officially places Iran into an exclusive club of elite nations leading the future of global aerospace engineering. We are now entering an era where the traditional boundaries between military engineering and science fiction become incredibly blurred indeed. The sheer complexity of maintaining stable flight while surfing on a wave of superheated plasma is a monumental scientific achievement. Every single component of the Fatah missile must perform flawlessly under conditions that would easily destroy any normal mechanical device. Engineers had to design specialized aerodynamic fins that can withstand immense structural stress without snapping off during violent evasive maneuvers. The internal solid fuel motor burns with astonishing ferocity, providing the massive initial thrust required to reach these extreme altitudes. Once the booster section detaches, the Hypersonic Glide Vehicle begins its terrifying descent, slicing through the air like a scalpel. Ground radars trying to track this descending glider often display scattered and confusing data due to the surrounding plasma interference. This electronic confusion gives the weapon a crucial tactical advantage, blinding enemy defense operators during the most critical final moments. The psychological impact of facing a weapon that cannot be stopped or even accurately tracked is truly devastating for militaries. Commanders are forced to completely rethink their entire defensive strategies, realizing that static fortifications are now essentially useless against hypersonics. Mobile defense batteries must constantly relocate, hoping to avoid being targeted by these incredibly fast and highly precise incoming strikes. The Fatah series represents a massive shift in regional power dynamics, forcing neighboring countries to carefully reconsider their military postures. Hypersonic weapons effectively shrink the battlefield, turning vast geographical distances into incredibly short journeys, measured only in a few minutes. A target located hundreds of miles away can be completely destroyed before warning sirens even have a chance to activate. This rapid strike capability ensures that high-value enemy assets, like aircraft carriers and command centers, are always under constant threat. Developing countermeasures against hypersonic glide vehicles is currently the absolute highest priority for leading defense contractors across the entire globe. Laser defense systems and advanced space-based tracking satellites are being rapidly developed to counter this incredibly dangerous new military technology. However, intercepting a maneuvering hypersonic target remains an incredibly difficult physics problem that no nation has fully solved just yet. The incredibly high kinetic energy of the Fatah missile means that even a near miss can cause massive structural damage nearby. Underground bunkers, previously considered safe from conventional bombing runs, are now highly vulnerable to these deeply penetrating kinetic energy strikes. The shockwave generated by a Mach 15 impact can crush reinforced concrete and shatter thick steel doors with absolute ease. Iran's successful test flights of these advanced weapons have sent massive shockwaves through the global intelligence and defense community recently. Many military analysts initially doubted their capabilities, but the verified flight data has proven the terrifying reality of these missiles. The aerodynamic design of the glide vehicle is a closely guarded state secret, optimized for maximum lift and minimal drag. Wind tunnel testing at hypersonic speeds requires incredibly massive power grids and highly specialized testing facilities that few countries possess. The computational fluid dynamics required to simulate these extreme flight conditions push the absolute limits of modern supercomputer processing power. Every single curve and angle on the missile's hull is meticulously calculated to manage the intense heat and aerodynamic pressure. Even a tiny manufacturing defect on the outer casing could cause catastrophic failure when subjected to Mach 15 atmospheric friction. This requires an incredibly high level of precision manufacturing and strict quality control throughout the entire complex missile production process. The navigation systems must also be incredibly robust, utilizing advanced inertial measurement units that can survive massive gravitational force loads. These sensors constantly calculate the missile's exact position and orientation in space, feeding crucial data to the autonomous flight computer. If the GPS signals are jammed by enemy electronic warfare, the internal navigation system takes over to ensure pinpoint accuracy. This autonomous capability makes the Fatah 2 virtually immune to conventional electronic jamming techniques, used by modern air defense network systems. The continuous evolution of this missile family suggests that future variants might fly even faster and maneuver with greater agility. We might soon see hypersonic weapons equipped with advanced artificial intelligence swarming capabilities, completely overwhelming any existing air defense network. The global arms race has officially entered a terrifying new chapter, where speed and maneuverability dictate the absolute ultimate victory. Nations are now desperately rushing to develop their own hypersonic arsenals to maintain strategic deterrence in this dangerous new era. The Fatah missile is not just a weapon, it is a powerful geopolitical statement demonstrating advanced technological independence and strength. It proves that heavily sanctioned nations can still achieve monumental scientific breakthroughs through sheer determination and dedicated domestic engineering efforts. The mastery of hypersonic flight opens the door to future aerospace applications, including advanced reusable spaceplanes and rapid transport. The technologies developed for these deadly missiles could eventually revolutionize civilian aviation, allowing incredibly fast travel across the entire globe. Imagine flying from New York to Tokyo in just a few short hours, riding safely inside a commercial hypersonic passenger jet. However, for now, this incredible technology remains firmly locked within the highly classified and secretive realm of advanced military applications. The terrifying reality is that a single hypersonic strike could potentially ignite a massive and uncontrollable global military conflict instantly. Strategic stability is now incredibly fragile as the reduced reaction times drastically increase the dangerous risk of accidental nuclear escalation. World leaders must now navigate a highly complex geopolitical landscape where traditional deterrence theories are severely challenged by hypersonic weapons. The Fatah series stands as a stark reminder that military technology is advancing at a terrifying and completely unprecedented rate. As we continue to push the absolute boundaries of physics, we must also carefully consider the devastating consequences of warfare. The plasma sheath surrounding the missile is a beautiful yet deadly phenomenon, representing the raw and untamed power of physics. Controlling this immense thermal energy requires a deep and profound understanding of thermodynamics, fluid mechanics, and highly advanced material sciences. The engineers who designed these systems have effectively tamed the fiery heat of atmospheric reentry for tactical military strike purposes. This incredible achievement demands a certain level of grim respect, regardless of the highly controversial geopolitical context surrounding its creation. The Fatah 2 glide vehicle dances through the upper atmosphere, a deadly ballet of mathematics, physics, and highly advanced aerospace engineering. It effortlessly evades the most sophisticated defense shields ever built, proving that speed and unpredictability are the ultimate tactical advantages. As defense systems slowly adapt, offensive hypersonic technologies will inevitably evolve further, continuing this endless and highly expensive arms race. The delicate balance of global power now heavily relies on mastering these extreme velocities and highly complex atmospheric flight dynamics. Iran's successful entry into the elite hypersonic club fundamentally alters the strategic calculus of the entire volatile Middle Eastern region. The Fatah missiles have permanently changed the rules of modern engagement, proving that technological superiority can emerge from unexpected places. We have witnessed how raw speed and advanced materials can completely shatter the physical limits of traditional military defense systems. Thank you for joining World Decoder today. Please subscribe to our channel for more deep dives into advanced military technologies.